In this last video for this week, I'm just going to quickly look through the graph code that's provided in the textbook. So there are a lot of supporting classes that go into programming a graph, but we're just going to look at kind of some of the basic classes that you need, and then also look at a quick driver program of how you'd use these classes to create this graph that we have been using in the traversals. So the main class here is directed graph. And there's an interface class, basic graph interface. There's also classes vertex interface. We use a dictionary interface. So as I said, there's a lot of supporting classes, but the main class here is the directed graph. And the way that we're storing a graph is with an adjacency list. So the methods that we have is add a vertex, so that adds a vertex to our graph, and then add an edge, which creates an edge between two vertices and connects them. So the way that you use this class to create a graph is that you first just instantiate an empty graph, and then you add a series of vertices. So for our graph we've been dealing with here, call this one here, we added 8 vertices, A, B, C, D, E, F, G, H, and then you just go through and add the edges directionally, the starting vertex and the ending vertex. So we have a vertex from A to B, so we added an edge from A to B. We have a vertex from A to E, so we added an edge from A to E. We also have a vertex from an edge from E to A, so we added that one as well down here. And we just went through and added all of the edges. Again, this is a directed graph, so we needed to add an edge from A to E and also an edge from E to A. The order matters here, again, because it's directed. There is a Boolean method hasEdge that tests whether there's an edge between two vertices. We have a test for whether the graph is empty, a method to clear the graph. We have methods to retrieve the number of vertices and number of edges in our graph. And then we have our traversal. So here you can see we have a breadth first traversal that again takes a starting vertex. So there is no just one single breadth first traversal for a graph. It's dependent on a starting vertex. So we need to send in that information. And this method returns a queue. That'll be the traversal order. So it returns a queue, and you can see the basic algorithm that we just walked through. We take our initial vertex and we put it onto the traversal queue. Then we just go through, we also add it onto the vertex queue. We then just go through the vertex queue as long as there's something in it, and we take the first element off the queue, we dequeue it, we put it onto the traversal order, and then we go through all of its neighbors, and if the neighbor hasn't been visited, we add that neighbor onto the vertex queue. Okay, so this is the basic algorithm that we just traced through. Similarly for depth first traversal. So for depth first traversal, we have to send in our starting vertex, and we're going to get back a queue that has the order. And so then we start with our origin. We put it on the traversal order, and we push it onto the stack, and then we just go through. Well, there's anything on the stack, we pop it off. Or actually, we're in this algorithm here, we look at it, and then we take all of its neighbors, push them onto the stack, and we take that top vertex and put it onto the traversal order. Okay. So again, these are the two algorithms we just walked through. There's also an implementation of the topological order and a method called find terminal, a display which will print out the adjacency list. Because our graph that we're using here is unweighted, it's just going to print a 0 for each weight, but this class for directed graph does support a weighted graph as well. And then there's a private class that helps support some of these other methods, and that is the directed graph class. So again, here we have our driver program where we create our graph, then add all of our vertices to that graph, add all of our edges. Here we invoke the display method, and then I've just invoked the get number of vertices and get number of edges methods, and then printed out the breadth first and the depth first traversals. Now note that for the implementation given in the textbook, the breadth first traversal will work exactly like the one we just traced through. But the depth first traversal actually, instead of using alphabetic order to push nodes onto the stack, it uses reverse alphabetic order to push nodes onto the stack, so that the popping off order is alphabetic. So the traversal is actually going to be a little bit different for the depth first traversal. using the code from the book than the one I just traced. But remember, both are correct. They just make different decisions about the order in which they visit neighbors. So if I run this little tester program, you can see that our graph has 8 edges and 13 vertices, which is what we've got here. Here is our adjacency list. So we have H is adjacent to E. So there is an edge from H to E. There's an edge from G to C. Again, all the weights are listed as 0 because it's unweighted. And from an edge from G to D, an edge from F to D, from E to A, E to D, E to F, D to B, C to D, B to C, B to G, A to B, and A to E. Again, 8 vertices, 13 edges. Here's our breadth first traversal starting at A. This will be the same one we traced through. Notice that H isn't listed. Here's our breadth first traversal starting at H. This will again be the same one we traced through. Here's our depth first starting at A. Again, notice H isn't part of it. I encourage you to trace through and make sure you can get this same depth first traversal if you use reverse alphabetic order for the order in which you push the vertices onto the stack. So I encourage you to do that and make sure that your order matches this order here. And then we have our depth first starting at H. And again, this is not going to be exactly the same as the one we just traced. It's going to be different. And I encourage you to see if you can get the same one in tracing through with that assumption. Okay, so that's a very quick walkthrough of the code. This is code you'll be using if you choose to do the Extra Credit Lab X, which I strongly encourage you to do. It's I think, kind of a fun little lab. It's purely optional, purely extra credit, but it'll give you some practice with the graph classes, and it's an interesting little one thinking about directed and undirected graphs. So post your questions about this code to the discussion boards, and I'll see you online.